All right, so Chapter 8, Lesson 2 is function rules. It says here, the China Palace sells lunch specials for $6 with a delivery charge of $5 per order. Fill in the table with the next 3 in the sequence. And normally these problems are finding the next 3 in the sequence, okay? So, little hint here. With ratio tables, you remember the ratio tables that we did previously? You were only allowed to use multiplication or division, right? With function tables, you use addition or subtraction. Okay, is everybody clear? So we need to look at the patterns. Okay, so when we look at the patterns, how do I get from 11 to 17? We're going to add 6, right? How about from 17 to 23? How about 17 to 23? Again, we're going to add 6. How about 23 to 29? Again, we're going to add 6. Is everybody clear? So, what do you think we're going to do to get from 29 to the next term? Add 6. Very good. So, what is 29 plus 6?
35.
Very good. And then we're going to add 6 again for the next term. So, 45 plus 6 is 41. And then we'll add 6 again for the next term. So, 41 plus 6 is 47. Is everybody clear? So the first thing we're going to look at is arithmetic and geometric sequences. Now it says here, you don't have to write this first part up here, just the vocabulary. Determining if a sequence is an arithmetic or a geometric can help you find the pattern. When you know the pattern, you can continue the sequence to find missing terms. Okay? So a sequence is a list of numbers in a specific order. Just like in our warm-up, let me go back real quick. In our warm-up, this is a sequence because it's a sequence. It is a list of numbers in a specific order. Now, each term, a term is each number in the list of the sequence. Let me go back to the warm-up again real quick. So a term here, 11 is a term. 17 is a term. 23 is a term. If you look at the numbers on top up here, this tells you which term it is. So 11 is the first term. You see that? 17 is the second term, and so forth. You got that?
Yes.
Okay. All right. Now, an arithmetic sequence can be found by adding the same number to the previous term. So in our warm-up, that was an arithmetic sequence. In a geometric sequence, each term is found by multiplying the previous term by the same number. And we're going to look more at geometric sequences today. So here, for the first 2 examples, it says describe the relationship between the terms in the arithmetic sequence 7, 14, 21, 28. Okay, then write the next 3 terms. So what you're going to do is you're going to say, well, let's see, how do I get from 7 to 14, from 14 to 21, from 21 to 28? Well, you add 7. Every time you add 7. Okay? In an arithmetic sequence, if you're adding 7, then adding 8, then adding 9, it is not an arithmetic sequence. You have to add the same number to the previous term each time. Is everybody clear with that?
Yes.
So 28 plus 7 gives me 35. 35 plus 7 gives me 42. So 42 plus 7 is
49.
49. Very good. Very good. So that is how we find the next three terms in an arithmetic sequence. For a geometric sequence, let's take a look. It says describe the relationship between the terms in the geometric sequence 2, 4, 8, 16. So from 2 to 4, we multiply times 2. 4 to 8, we multiply times 2. 8 to 2, we multiply. 8 to 16, we multiply times 2. So 16 times 2 gives me 32. And then 32 times 2 gives me 64. And then 64 times 2 gives me 128. Is everybody clear with that? So here we have a few examples, and when we do this, we are going to look for the next three terms in the sequence, okay? Now, and I'm going to show you how to show your work. So let's see here. The first sequence, we have 0 to 15, 15 to 30, and then 30 to 45. How do I get from 0 to 15? We are going to add 15. Very good. How do I get from 15 to 30? We add another 15. Good. And then how do I get from 30 to 45? Okay, so we added 15 every single time. We got the terms. How do I get from 45 to the next term? You're going to add 15. So 45 plus 15 gives me 60, right? 60 plus 15, let me put this down here, plus we go to the next three terms, right? So 60 plus 15 gives me 75, right? And then 75 plus 15 gives me what? 90. And there's your next three terms. Is everybody clear? Example. Looking at example B, how do I go from 4.5 to 4? Minus 0.5, right? And how do I get from 4 to 3.5? We're going to subtract another 0.5. How about 3.5 to 3? Minus 0.5 again, right? So how am I going to get from 3 to the next one? Minus 0.5. So 3 minus 0.5 is going to give me what? 2.5. Got it? So now, hold on a second, 5. How do I get from 2.5 to the next term? Again, minus 0.5, right? So, oops, that gives us 2. And then finally, to the last term, 2 minus 0.5 gives us 1.5. Very good. All right, so that's example B. So what kind of sequences are those? Arithmetic or geometric? Those are arithmetic. Very good. All right, so let's take a look at C and D. Okay, so how am I getting from 1 to 3, 3 to 9, 9 to 27? Times 3. Very good. And every time we are multiplying times 3. So to get from 3 to 9, we multiply times 3. And 9 times 3 is 27. Is everybody clear with that? So how do I get from 27 to the next term? Times 3. So 27 times 3 is 81. And then we multiply again times 3 to get 243. And then we'll multiply again times 3 to get, very good, 729. Has everybody got it?
Yeah.
All right. And finally, what am I going to do from 3 to 6, 6 to 12, and 12 to 24? Times 2. Piece of cake so far, right?
Yeah.
So times 2. Every time we're multiplying times 2, times 2, times 2. So how do I get from 24 to the next one? Which gives me 48. And then 48 times 2 gives me 96. And then 96 times 2 gives me 192. So now we're going to find a rule, okay? A sequence can also be shown in a table. The table gives both the position of each term in the list and the value of the term. Okay, so just like in our warm-up where we were saying the first term, second term, third term, here the position and the value of the term. So up here, 1, 2, 3, 4, this is the first term, second, third, and fourth term. Is everybody clear? So the second term is 16. Got it? It says you can write an algebraic expression to describe a sequence. The value of each term can be described as a function of its position in the sequence. So that means that the position, you're going to perform an operation on it to get to the value. All right. Now, in this table up here, it says the position can be considered the input value and the value the output. So if the position is the input, which letter is that? Which variable is that? If it's the input, it is the x. And if it's the output, it's the y. Is everybody clear? All right. So let's look at these examples. Well, this example. It says, use words and symbols to describe the value of each term as a function of its position. Then find the value of the 10th term. Okay, so here we want to figure out what is the function rule. Okay, the way we do that is we look at the patterns in the table. So, looking at this pattern, how do I get from 3 to 6? Plus 3. And then from 6 to 9, plus 3 again. And then from 9 to 12, plus 3 again. Now, if it said plus 3, plus 4, plus 5, then it's not an arithmetic sequence, okay? It has to be, you have to add the same number every time. Now, because it says plus 3, plus 3, plus 3, that 3 is going to have something to do with the rule. Okay? So, it's going to be 3 something. So, look at the term, and we want to look to see how do I get from 1 to 3 using a 3. You're going to multiply times 3, right? So 1 times 3 gives me 3. Let's check to see if that works for the rest of them. 2 times 3 gives me what?
6.
Check. 3 times 3 gives me what?
9.
And 4 times 3 gives me
12.
12. So the rule here is that we're going to take that 3 and we're going to multiply it times the input value, which is n. So there is my rule, 3n. Is everybody clear? So then it says, find the value of the 10th term. So if we're looking for the 10th term, what is n going to be? if I'm looking for the 10th term, n is equal to 10. Is everybody with me? So now if n is equal to 10, my rule is 3 times n. I have to just substitute 10 in for n, right? So this is going to be 3 times times 10, which is equal to 30. All right, so let's do example E. How do I get from 12 to 18? Plus 6. And then how about 18 to 24? Plus 6. And then 24 to 30? Again, plus 6. So that means that that 6 is going to get multiplied times the input value, right? Times the n. Got it? So that's going to be 6 times n. Now let's check it out. 6 times 2 is equal to 12, right? 6 times 2 is equal to 12, so that works out. So I didn't have to I didn't have to add anything to the 6n, right? Like we did over there with the example F, right? So here, 6 times 3, check. 6 times 4, check. And 6 times 5, 30. Now, we're going to look for the 8th term, okay? So, for the 8th term, n is equal to 8, right? So, we have 6 times 8, which is equal to 48. So, if I'm looking for the 8th term, that would be 48. So now we've got letter F, okay? So the first thing again we're going to do is we're going to look at the pattern in the sequence. So let's see. Each time, what's happening? Plus 1, right? Plus 1, plus 1. So every time we're we're adding 1 each time. So that means that this rule, that 1 is going to be involved somehow in the rule, right? And how did we say it was going to be involved? It's going to get multiplied by the term number, right? So here, this 1 will be multiplied by the term number, and it's going to be n, right? So 1 times n. Is everybody with me so far? Now, let's check. 3 times 1 is not 7. So how would I get 3 times 1 to 7? What do I have to do to it? Add. No. Add. How do you get from 3 to 7? Add 4. Okay, so we're going to add 4. All right, so we have 1 times n, and we got that 1 from this pattern down here, right? But then we said 3 times 1, that doesn't give me 7. In order for us to get to 7, we have to add 4 more. So the rule here would be 1 times n plus 4. Can I simplify 1 times n? Yeah, that's just going to be n plus 4, right? So let's see if that rule works for our table, for our sequence. So 4 plus 4 is equal to 8. 5 plus 4, 9. 6 plus 4, 10. Good. So that means that our rule is n plus 4. Now we need to find the 8th term. So that means that n, again, is equal to 8. So we have 8 plus 4, which is equal to, very good. So our 8th term is equal to 12. All right, the table shows the number of necklaces Ari can make based on the number of hours she works. Write a function rule to find the number of necklaces she can make in X hours. So once again, we are going to look at our pattern, okay? And this is just a table that is vertical rather than horizontal, okay? So how do I get from 5 to 7? Plus 2. And then 7 to 9 plus 2. So again, that means that that 2 is going to be multiplied times our term number. Is everybody with me? So we know that the first part of our rule is 2 times x. Okay? So now let's check it out. 2 times x. 2 times 1 is 2, not 5, right? But how can I get 2 to 5? Plus 3. Very good. So now, let's see if that function rule will work. So we've got 2 times 1 plus 3. So 2 times 1 is 2, plus 3 is equal to? 5. Very good. How about 2 times 2 plus 3? That's 4 plus 3. Check. Very good. And then how about 2 times 3 plus 3? So that's 6 plus 3. Check. Very good. So what is the rule over here going to be? 2x plus 3. Is everybody clear?